In this lesson, we're going to be talking about writing linear equations in slope-intercept form. By the end of this lesson, you should be able to write linear equations in slope-intercept form and model real-world data with an equation. Now, up to this point, we've been graphing with these linear equations, but we're going to begin writing with them in these next couple of videos. And so the three most common forms of linear equations that we've talked about are standard form, slope-intercept form, and point-slope form. And the linear equations that we're going to be representing, the linear relationships that we're going to be representing, can all be written in any of these three forms. Now, when we're writing an equation in slope-intercept form, there's two things that we're going to need. We're going to need to find the slope, and we're going to need to be able to find the y-intercept, because we're writing these in slope-intercept form. And so to write them in slope-intercept form, we're going to need the slope and the intercept, that y-intercept. Sometimes finding the y-intercept can be a little tricky, and so as long as we have the slope and a point, we can substitute in those values into the equation and we can solve for the b. Otherwise, we will be looking at the graph to find the y-intercept, or we'll be going back in the table until we get the x value of 0. Okay, so when we're writing equations in slope-intercept form, sometimes we're given a different equation and we need to manipulate it or rewrite it so that it's in the form that we want. And so we would do that like we would any other literal equation. And so remember that slope-intercept form is this y equals mx plus b. And so the goal is to get the y by itself. So here we have an equation that's 38 minus 11y equals 44x plus 5. And we're going to solve it by getting the y by itself. So we're going to first subtract the 38 from both sides, moving that away from the y. It takes away the 38 from this side. And what we're left with is negative 11y is equal to 44x minus 33, because 5 minus 38 is 33. And then the last thing that we would do here is we would divide everything by negative 11, because we would need to move the negative 11 away from the y. So now what we'll have is we'll have the y value by itself. 44 divided by negative 11 is negative 4x. Minus 33 divided by negative 11 is plus 3. And so here we have our equation in slope-intercept form. Y equals negative 4x plus 3. And now we're able to identify the slope from this, which is negative 4. And we're able to identify the y-intercept, which is 0, 3. Sometimes we're given a graph and we're asked to find the we're asked to write the equation for this linear relationship. And so again, we're going to need two things here. We're going to need the slope and we're going to need the y-intercept. Remember, to find slope, we're finding the change in the y over the change in the x. So we pick 2 points. So we pick 2 points. Keep in mind that when we're looking at change in y over change in x, we need to keep the scale in mind. So the scale on this graph is going by 0.5s, and so we just need to kind of keep that in mind as we're counting. So to get from here to here, we're going to get from this negative 3, 3 to 0, 1. I'm going down, that's 0.5, and then that's 1, 1.5, and 2. So we went down 2. And then for change in x, that's increasing 1 or 0.5, 1, 1.5, 2, 2.5, and 3. So we have a change of negative 2 because we went down 2, and an increase of 3, a change in y, a change in x of positive 3 because we went over 3. So our slope for this graph is negative 2 over 3. To find the y-intercept, we're simply looking at where does the line cross the y-axis, and we see that it crosses the y-axis at 0, 1. And so now that I have my slope and my y-intercept, we can write the equation. Remember that we're writing this equation in y equals mx plus b form, so we're writing it in slope-intercept form. The m is negative 2 over 3, or negative 2/3, x, and then our y-intercept is positive 1. So our equation is y equals negative 2 over 3x plus 1. We also need to be able to write the equation from the linear equation from a table. So again, we're going to need our two things. We're going to need the slope, which is m. We're going to need the y-intercept, which is b, because again, we're writing this in slope-intercept form. So we need the slope and the intercept. Remember, to find the slope, we're looking at change in y over change in x. So my change in my y's is an increase of 3. So if I go throughout this entire table, we'll see that the y's are increasing by 3. My change in my x is plus 1. So if we continue our pattern in this table, we see that change in x is 1. This can be simplified to positive 3. Now to find the y-intercept, remember that the y-intercept is when x is 0. So in this table, I'm going to need to go back so that x becomes 0. So I need to go back in the table. So I go 1 back to get to 0 from 1. If I'm going 1 back, that means on the y side I have to go back by 3. So 12 minus 3 is 9. And so we have a y-intercept of 0, 9. And so now that we have the slope and the y-intercept, we can write our equation in slope-intercept form. So remember, slope-intercept form is this y equals mx plus b, our m, our slope being 3, our y-intercept b being 9, and so our slope-intercept equation would be 3x plus 9, or y equals 3x plus 9. We can also write the equation of a line given just 2 points. As long as we can find the slope, we can use the slope and our points to figure out what the y-intercept would be. So we want to start off by finding the slope. And so we use the slope formula. This is the y2 minus y1 over x2 minus x1. And so we need to label our points. This would be x1 and y1, x2 and y2. Remember, I label the points just so that we get them in the right spot. Our y2 in this case would be 3 minus y1, which would be negative 1, over x2, which would be 2, minus x1, which would be 4. And so 3 minus negative 1, that would change to 3 plus 1, so it'd be 4. 2 minus 4 would be negative 2. And so 4 divided by negative 2, or 4 over negative 2, simplifies down to negative 2. And so we have a slope of negative 2. Now, we need to find the y-intercept. I don't have a graph, I don't have a table to go back and find when x is 0. So our alternative is to take the equation that we know that we're going to be writing and substitute in some values and solve for b. So here is what we're going to do. We're going to write the slope-intercept form equation with what we know. So remember that the slope-intercept form equation is y equals mx plus b. We know that m is negative 2. So I can replace the m with the negative 2. And then we also have 2 points. I have 2, 3, and I have 4, negative 1. I'm going to pick one of those points. I'm going to pick 2, 3, just because both of those coordinates are positive. And I'm going to substitute them into the equation. So if I have the slope and I have a point, I can put in the information for that point. So I can put in the y value, which is 3. I can put in the x value, which is 2. And now all that we're missing is b, and I can solve this equation and figure out what b is. So negative 2 times 2, that's negative 4. Plus b. We have negative 3 on this other side. And then again, the whole point is to figure out what b is. And so now I'm going to add 4 to both sides so that I get b by itself. And the 4 should go away there. We have negative 3 plus 4, which gives me positive 1. And so we have b is equal to 1. So we know that the slope, the m, was negative 2. So we found that over here. We know that b was 1. And remember, we found the slope, we found the y-intercept by plugging in the slope and a point into the slope-intercept equation and solving for b. And now that I have my m and my b, I can go back and we can write our equation. So this would be y equals 2x plus 1. Given a real-world situation, such as the following situation, where Paintball Extreme charges $15 charges a $15 entrance fee plus $2 per hour. We want to write the equation. We want to write this equation in slope-intercept form. This is a linear relationship because we have a rate of change, which is at $2 per hour, so we know it's linear. So if I'm writing a slope-intercept equation, remember that we need two things. We need the slope and we need the y-intercept. The slope in this case would be our rate of change. So our rate of change is $2 per hour, so in this case would be 2. And then our y-intercept, this would be the initial fee, the initial amount, this one-time fee. And so in this case, that one-time fee is $15. And so now that we know that the slope is 2 and the y-intercept is 15, we can write our equation, which would be y equals 2x plus 15, because this would be that y equals mx plus b form. Before watching the next video, what I would like for you to consider is how to write an equation in slope-intercept form. As usual, please subscribe to the channel so that you get updates on when new videos are released.